All right, so let's talk about some important integrals that we should probably know. So, if you have the integral of dx and there's nothing in front of it, then the uh, integrating it yields x plus a constant. Super easy. If you have an integral of a constant k times f of x, well, you can pull that constant out in front of your integral, and it just becomes k times the integral of f of x dx. If you're integrating the sum of two functions, you can split it up into two separate integrals. So integral of f plus or minus g is the integral of f plus or minus integral of g. So you can kind of split it up over addition or subtraction in order to make your integration a little bit easier. Then, if you have the integral of x to the n, this is like undoing the product rule. So the integral of that, you're going to raise it to the power of x to the n plus 1, and then you have to divide by n plus 1. Why do we have to do this? Well, think about going backwards, right? If you have x to the n plus 1 over n plus 1, and we do the power rule, n plus 1 comes down, and that will cancel with what's here in the denominator to give you a coefficient of 1 here in the front. This rule, of course, only works if n is not equal to -1. We'll talk about that shortly. Next thing we're talking about, u substitution. All right, if you have a complex form of an integral, something like integral f of g of x times g prime of x dx. We're going to use this substitution, and we use the letter u for it. That's why we call it u sub. We're going to say u, the letter u, is this entire function g of x. And the derivative of u, du, is how we're going to write it, is g prime of x times dx. And so we can substitute this in, and this becomes the integral of f of u du. Let's look at an example of how this works. So if you're having the integral of x cubed minus 7 cubed times x squared dx, we're going to let u be x cubed minus 7. Why did we pick this? Because it looked like the ugliest part of this whole thing. There's obviously slightly better reasons, but that's generally, when you're doing u sub, if it looks ugly, it's probably going to be the part that you're substituting. So if we take the derivative of this, du equals 3 times x squared, the minus 7 goes away, so 3x squared dx. So in our function that we're looking at here, we have an x squared dx. So we can rewrite this in order to be able to substitute it. We can divide both sides by 3 and get du over 3 equals x squared dx. Now we have everything we need to just plug and chug into our substitution. This is now the integral of u cubed times du over 3. Right? This is u cubed, x squared dx is du over 3. Now, we pull the 1/3 out because it's a constant. We can use our product rule inverse from the last slide to say, well, this part would be u to the 4th over 4 times 1/3, and then we've got a constant here at the end. And now, all we have to do is just sub back in for u. So instead of u, we're going to write x cubed minus 7. So our final answer is 1/12 x cubed minus 7 raised to the 4th power plus some constant. There we go. That's how to do u substitution. Last thing we're going to talk about is a few other helpful rules. If you've got some function like u to the n times u prime dx, well, this is just like this. This is basically just looking at the product rule, or not the product rule, the power rule, and undoing the power rule. Here, same thing, e to the u times u prime dx. The integral of that is just e to the u. This one's really important, and this one might trip you up. Integral of u prime over u times dx is natural log of absolute value of u. All right? You have to use the absolute value when you're doing this. Otherwise, it is wrong. Then, if you have a trig function, you should probably look it up. There are obviously other far more complicated integral methods. We'll talk about one of them in another video, but most of them I recommend you just check out in your calc textbook, look up somebody else's videos, or look up the problem in a table of integrals. As always, thanks for watching. We'll see you next time.